I think that's enough of an intro. I have this very strange urge to say good morning everyone, but it's Friday night, a bit of an impromptu live stream. Kind of impromptu. Let's get right into it. Dana, hey, thanks for coming along. Heinrich, g'day. Cabletti. My turn to have a birthday in lockdown. No. I've had 2 birthdays in lockdown now. Great timing. All right, so what are we going to do today, brain? Because this is at an unusual time, I feel totally out of place. Like this is not what I'm meant to be doing at all. It doesn't feel like I should be live streaming. All right, so the mission for today is to put some of these parts on a board, and I have the board here. So maybe we'll get there, maybe we won't. Maybe it'll work, maybe it won't. Let's give it a shot. Gotta get some focus on there, otherwise I can't zoom. Yeah, so, hang on, gotta zoom that way. It's really annoying in Eagle that you can't pan once you hit a certain limit unless you zoom in or out and around and about. Now, cable tie, no live stream or party poppers. No, I've got party poppers. You're not that far from me. We can arrange party poppers. I could drive outside your house and blow off some party poppers. So, what we have is this. And that is what we have been excited and anticipating for the last little while, getting some parts onto this board. And I do not yet have the PoE regulator that goes on here, but just today I got a delivery from DigiKey, which got me some extra CP2102Ns, and I got a delivery from, I got the delivery from Arrow with the W5500s, although I already had some of those, but now I have more, which is good. So I do actually have a stencil for this, but I'm not going to use it. I am going to just paste this one up because I'm going to do this treat this as a kind of piecemeal. So I'm going to come over here and bring this chat up bigger because I want to at least keep half of an eye on the chat as I'm doing this. It's too far away. What I need is chat on the bench right here. I should put it up on this other monitor. So what I'm going to do is just hand paste this, which is, it's okay. Hopefully not too much of a disaster. It might take a little while actually. There's a little bit on this board, but I don't know what I will do while I'm pasting up. What will I talk about? Okay. Hopefully, I am terrible at multitasking. It's one of the limitations that I've learned about myself over the years. I need to just do one thing, and while I'm doing it, that's what I'm doing. I'm much more efficient than trying to do 2 things and failing at both of them. But I might be able to talk about something. So, I need to relax. All right, now am I going to do each of these? Yeah, I'm probably going to end up reflowing this anyway, so I'm just going to smear some paste around the pad sort of area. What often ends up happening with these QFNs, if the paste isn't just right, then you end up with bridges and things not working properly. And I'm not going to be able to get the paste just right by doing it with a syringe. So what happens is I get it in place, run it through a reflow, and then typically I will, if it doesn't work straight off, which often it doesn't, just put a bit of paste in those big mechanical holes. Which reminds me, can you see this? Yes, you can. Very good. What is the tool that I'm using to put solder paste? Just a syringe. Nothing more exciting than that. So I'm using this. Just ChemTools solder paste. Very easy. What was I saying? That's right. So yeah, what ends up happening is I take it out of the oven and then often have to just put some flux on it and hit it with the hot air, wiggle it around a bit. That makes all the solder even itself out. Oh, I'm really bodging this up. It's not releasing from the tip of this syringe very well. It's and as you can see, the tip is a bit mushed around. This one's a bit bent. Okay. Oh, oh no, that's all right. There are a few parts that I don't have, and prior to this, I got out the PCB preheater and the hot air, and I warmed up some boards that are in my my trash pile, and pulled off some bits, because there are some of the parts for this that I've ordered but haven't arrived yet. That's better, it's releasing from the nozzle tip better now. And one of them, what reminded me, is this part right here. This is the polyfuse, the PTC. So 500 milliamp fuse to protect the host computer if you plug this into a USB port. And I have actually run out of polyfuses. In fact, I've assembled a bunch of ESP flashes and I didn't have enough polyfuses for them all. So I've got, what else, if I missed parts down there? Yeah, how will I do this? I think I will work down one side of the board because it's kind of long and narrow. Yeah, okay. What part is this? I can't remember. Oh, this must be the temperature sensor. Yeah, it would be. MCP9808T, which I've just started using on quite a few projects. I used to put BME 280s on just about everything, and they went up in price quite dramatically because of the whole chipocalypse. And so I was looking around for an alternative cheap and well supported temperature sensor, and the MCP9808 seems to be a pretty decent one. So I've ended up putting that on a bunch of projects over the last month or so, probably. Back down to here. What have we got? What is that? Oh, that's a tantalum capacitor. Don't even know if it needs a tantalum there, but that was what was in the reference design. It's what I've always put on the Ether Mega and Ether 10, and now on the Ether Uno, although I can't actually produce the Ether Uno at the moment because of lack of parts. So I normally try to avoid tantalums just because they're so expensive. But do the dodgy run a bead across all the pads thing. Probably have to clean this up in post. As soon as the solder paste gets warm, it all runs everywhere anyway. It follows wherever gravity and surface tension decides to take it. Oh, that's right. I was going to say something about stencils. So I had a stencil made for this, but the time involved in setting up the board holder to get it in the right position and cleaning the stencil afterwards and things, it's not really worth it just for one board. If it was a more complex board, I would probably use the stencil even just for one like this. But it would take me longer cleaning the stencil afterwards than I will spend now just putting this paste on by hand. So, and I'm not as precise as the stencil, but hopefully it'll get the job done. Yeah, you can see that a lot of these pads aren't actually connected. These ones down the middle, and I'm putting solder paste on them anyway. I got into the habit of doing that. Like I paste stuff up on parts that have got multiple what what am I trying to say? I end up putting paste even on pins that aren't connected, simply because it makes the surface tension even up better and stuff doesn't tend to move around, doesn't get pulled sideways. Now, in a moment, I'm going to take a squiz in the chat just in case I'm missing anything important. Oh look, a squirrel is eating the VREG. There's Steve. Right, and I am going to, we've got a through-hole regulator here. This is, and I'm going to paste that up because I'm actually going to pre-cut the leads, like bend and pre-cut the leads on that regulator and stick it in and have it sitting in the board with the leads going through these holes and have it on when it goes through reflow, because that way this big thermal mass right here will have the best possible chance of all being flowed properly. Now I think that is all pasted up. I'll need to do a quick look at the board overall, but while I've got it under here, a couple of things I did. One is you can see the sides here, it's got thermal relief on this pad, but that works against you when you want to try to get heat off the voltage regulator. So you can see the very small connection there, there's a small connection there. This is the normal thermal relief connections. But what I did on the board layout was I ran a thick track from the center of this pad straight out, and that's why this connection is thicker. And then I've put vias here for thermal stitching and vias there. So it's a 4-layer board with thermal stitching through to the other layers. 3 of the layers have ground pores on them, and 1 has a 3.3 volt pore. So we have 3.3 volts everywhere. I think I got all of the things. Now, we'll move it over to this camera. And what I usually do at this point is basically hold it up and get the light shining off it. Like if I get the right angle like this, it's not very easy to see on camera. I can see it much easier with my own eye. But this is a test to see if there are any pads that I haven't pasted up, because there should be the dull grey colour everywhere. And if I tilt the board around and get it at different angles, if I see bright silver shining off different pads, that's an indication that there are pads that I have not yet put paste onto. Okay. Mihu, having breakfast. Oh, so Carlos asked why not a stencil. Yes. And Dana, you were arting for a bit. Aren't you always arting? That's kind of your thing, isn't it? When you're not messing with people's minds and making me question reality. Actually, on that subject, there was a thing you posted on Twitter, I don't know, maybe a week ago, where you were messing around with well, there are a couple. There was one where you were messing around with a keyboard and blanking out some keys using tools in Photoshop to pull it out, but that was so fast. I sat there watching it, and in the space of like 30 seconds, you'd basically like de-buttoned a part of a keyboard. Is that really how fast you can work? Because that was amazing. So, wow, we're up to 90 viewers. For a bit of a silly impromptu live stream, we've got more people on here now than we often get on a Sunday morning. All right, now, what I would like to know is, oh, Cable Tie says, what do you art in? To Dana. Yes, what Dana arts in is gaslighting us and trying to convince us that what we think is reality is not reality, or that figments of Dana's imagination are reality. And either of those can be equally horrifying or inspiring, amazing. There are some things that that I just want to build. All right, so now I want to, no one's commented on this. So Mr. X, Mr. Y, what time is it here? It is now almost 9 p.m. Yeah, I was intending to live stream this early this afternoon and the day got away from me. All sorts of things happened. And that's just the way it ended up being. Okay, now, I did something this afternoon in preparation for this live stream that no one has yet noticed or commented on. So pay close attention and see. I just want to see if anybody notices what's going on here. So let's just have another look at this under the microscope. And no real reason other than the fact that I wanted you to look under the microscope again. Yeah, that paste job around there looks pretty dodgy. But now I can just slide across to here and we're on the overhead camera. I know, I am pretty proud of that. I don't know if anybody's noticed yet what happened. All right, back to here, microscope, overhead camera. All right, now I need some parts to put on this board. Usually at this point, cable tie, got it, yes. Video tracking. So what it actually is, if I switch, so I'm going to manually switch to the side camera. I'm not going to put my hand in front of it. Just there is an ultrasonic distance sensor attached to the front of the microscope. So, and that's attached to a Leo stick, which is sending hotkeys to OBS. So if I put my face in front of the microscope, it switches to the microscope view. And if I take it away, it switches to the overhead view. So if I just put my hand in front of it now, it goes to microscope view, take my hand away, overhead view, microscope, overhead. So I thought that would be a cool thing to have while doing assembly, because what I can do is be sitting over here, putting parts on and switching between being on the bench and using the microscope. Ooh, DefPom said, I built an IR sensor for my desk to do the same thing, also using a Leo stick. Awesome. Okay, now I need some parts. So that's right. What I was getting at before is normally at this stage of the thing, what I have is an assembly guide, and I have not yet created one for this board. So this is my normal process. I'm not actually going to go through it all now because it's kind of annoying to see it all. It'll take a while. So what I would do is go grid. Let's make it 0.1 millimeter. So give it a really small grid. I'll do change size and I'll make it 0.8128. And normally you do, the quick way to do this is a group select and then do a group change. So change the size on all of the values. And my personal preference is that on assembly guides, I don't have designators. I only have values. So when I'm doing assembly, I don't actually care if, for example, this capacitor, what is it? Well, we know it's 100 nanofarad, but what is it? It is C7. But who cares if it's C7? I want to know if it's 100 nanofarad. So what I do is go through and put, make all the designators 0.8128, and then with the grid nice and small, I just put all the values in an appropriate place like this. Oops. Spin it around and let's move these out of here to clear up some room. Where is that one living? That one is that one there. It's 10 microfarad, that's 100 nanofarad. And in fact, switch to T values as the primary focus layer. So yeah, what I do is just go through and put everything where it's meant to be like this, and then I actually print out a hard copy. So normally when I'm doing assembly, I will have a hard copy of this sitting on the bench right beside me, And then I can just look at that and see, oh, I've got to stick some 10 microfarads down there, there and there. And I don't have to keep looking back over at Eagle or anything. And you can see in here it's a bit of a mess, it's a pain. So that would need to be cleaned up. But I'm not going to do it right now. I'm going to do it the dodgy way of sliding across to the screen, I think. But what I have, if I'll show you some examples of what's normal. Better move that out of the way so that so I've got these plastic slips. They're just, you know, designed to have documents shoved in them, and then I just print out. So this is the LinMod module. LinMod. So this is the LinBus interface module that I use for controlling the electric, the motors in my electric windows in the house. And you can see it's just got the values, and I just print it A4. You can see in the little view there, I just zoom it so that it's as big as possible, and all it does is show the values. What else have I got? That's an assembly guide for the IO Relay 8, all the values there. What's that one? Oh, that's a wheelchair breakout. Anyway, lots and lots of them. So I've got a big stack of these assembly guides. DIN Relay 8, oh, that was something that I never released. I made one and it was cool, but I got scared off by the idea of releasing something that, that switches mains, and there's a whole certification issue going on. All right, so let's put some parts on the board. Now, the other thing is that I could be picking and placing this, but I'm going to be the pick and place machine for today. Hi, I'm John, and I will be your pick and place machine. So, which way around? What do I need? Let's start with let's just start with some resistors. Grab the resistor kit. That overhead camera is really zoomed in. Oh, that's something else that I'm working on doing. This is not, yeah. This is a 3D printed ring that's going to go around the camera with a GT2 belt on it, going to a stepper so that I can remote zoom the camera. But that's a project that is currently a work in progress. All right. So, parts on the board. What do I want? 4K7s. Where do the 4K7s go? Let's go to... I'm going to sort by value. I know you can't see this. I'm sorry. And step through the location of the parts. All right. I've got a bunch of 1Ks to put on. There's a 1K, there's a 1K. This is really not going to be an exciting spectator sport. But if you were foolish enough to come along to this show, where am I looking at on the board there? How have I lost that? Have I got it upside down? Which way am I even looking at this? I ended up orienting the board in Eagle kind of backwards conceptually because of the way the silkscreen works and because of the way it's going to fit inside the rack enclosure. So what am I looking at here? There. Oh, it didn't switch. That's better. Because of the way it's going to fit inside the rack enclosure, which means that when it's up against the edge of the case. Hang on, why are these 1K resistors? Oh, it's because they are not blue. In fact, while I'm here, let's just stick them on. What have we got? TX. It says green and yellow, but I'm just going to stick green on both of them because that's what I've got in my hands. And they are, which way is the anode? Anode is down, which is lucky because that's the way that I picked up that particular diode. Now I've got to pick another one up the same way around. Yes, that way. What else do we have in this area? Rather than going by value, I'm just going to work through different zones of the board. It's going to save a whole lot of scrolling around. So I've got a bunch of 10Ks to go on there and a 1 microfarad, but I'm going to leave the caps for a little while. So, yeah, at this point, actually most of the time, I don't even use the microscope when I'm doing this part of the assembly for these bits. Where is it? I've got to get it in the view of the overhead camera. It's quicker not to use the microscope because it means moving your head over it and then pulling back out to change your field of view, etc. And it can be quite slow. It's quicker just to put them straight down, provided you can see them clearly enough. What am I looking for? 10K goes there. And then we can look under the microscope later and see what I stuffed up. While I've got the 10Ks open, I think there were some resistor networks. Those are 10K as well. 10K. What I should have is the... Do I have screen? No. What I was going to do was add a little side view of my desktop into this same view so that you can see what I'm looking at in Eagle, but I don't think it really matters. All right, 10K resistor networks. Let's put those in. There. And that was it. That was the only 10K resistor network I had in my little box, which I don't normally have in there anyway. It's just that I had one that had come off a tape on the pick and place machine, so I chucked it in with the 0603s. Yes. What am I looking for here? What part of the board are we at? Up there. 1 meg. Let's put a 1 meg up there. On the... Where is it? Just next to there. Okay. 1 meg. And we need a couple of 18 picofarad caps. No, I'm going to leave the caps. I'll come back to those. 4K7s. There'll be a couple of 4K7s on the board. We need one there. We also will need them for I2C pull-ups, of course. So that one goes on there. I2C pull-ups. Where are they? There. So those two will also be 4K7. And they are. That one there. And the other board that arrived in this same shipment is these ones, the little breakouts for the SPI LCD. So I'll have to assemble one of those at some point as well. Probably not tonight though. Alright, so a bunch of 470Rs. That's a low value. That's for the activity LEDs for Ethernet. They're only running on 3.3 volts, so 470R I suppose is reasonable. And while I had the LEDs out earlier, I should have put those on. Maybe I should look out my my miscellaneous LED color pack and put some, since this is a prototype, we can go a little bit crazy and put some bizarro color LEDs on it. So Weird thing is, I was just about to try to zoom in the overhead camera view. That doesn't work. I scroll in it. 470. So what have we got? 10K. 10K. We've got another 10K up there. That one. I've got to try to do this without sticking my head in the view of the thing. How far can I get? About there. You don't want to be looking at the back of my head. Or the front. What else do we have? Alright, let's do... Yeah, there are some odd values here. There's a 12.4K 1%. There are a couple of reference resistors that are used by the Ethernet chip that are that are very specific and that I do not have reels of. I've only got like small numbers of them in my resistor kit. Oh, while I'm here, I'm going to chuck on that tantalum. I stripped this off another board just earlier. In fact, I've got a few parts here. This is the SD card socket. You can see it's kind of looking a bit horrible. I put a bunch of flux on it, put it on the preheater, and flowed this off another board, and then put it in the ultrasonic bath and chucked it in the dehumidifier for a while, and it's still got those discolorations on it, which is a bit unfortunate, but at least it should allow us to test the functionality. So looking at, there's a 1K. When I'm actively doing something like this on a live stream, I need an offsider. I need a partner, someone here to talk to you all. So a couple of 49R9s, yeah, that's another very specific value. 49.9 ohms is typically used in, see these ones right here, they're typically used in, there, in Ethernet connections. I am going to rearrange these ones just to make it a little bit more logical, and I should resize that, but I won't. Spin the anchor. And yeah, so 49R9 is a value that you see a lot in stuff with Ethernet on it. And unfortunately, that's also one that I do not have as a reel. I don't think I do. Maybe I bought a reel of those. I can't remember. My reel inventory management system is looking at the pick and place machine and seeing and taking an estimate of how much is left on it. And I need to build one of Sion's really cool little reel management systems, because I just have like a big box full of reels. It is not at all a neatly organized collection. And every now and then I look through the box and go, oh, that's right, I forgot I had those parts. What have we got there? 4K7, I've done that. There are a couple of, yeah, these specific values here as well. 47.5K and 22.1K. These are part of a reference voltage divider that goes into the CP2102N. And also 5.1K, you see those. Anytime that you've got like a USB-C connection that is being used in USB v2.0 compatibility mode, if you put a 5.1K pull down resistor on these signaling lines, it indicates to the host that you want power. Give me power, please. So I do have a reel of those because they go on everything, pretty much everything now. Like in recent times, there's only one thing that I've designed that hasn't had a USB-C connection on it. It's had a USB type B, one of the big square ones. And while I'm talking, I'm not getting anything done. What am I looking for? 47.5K, 47, there it is. 40, there aren't any 47.5Ks left. Not in my little kit. I thought I had some. Oh, there we go. Yes, I've got a whole reel of 47s, but it's on the pick and place machine. So I can fudge it, drag the tape through the machine, and scavenge myself apart. Next time the machine starts up, the cover tape on that reel is going to be slack, and it's going to detect it and roll it back up again. So where does that go? 47, where? Oh, there. 47.5, then I might as well put on the 5K ones. That little double tap that you hear each time I open one of these, it's because I'm in the habit of tapping the doors on the little parts container, because the parts can end up being electrostatically stuck, which is not a good sign, but it happens. They end up getting stuck to the little doors, so I can use that as a shortcut now to change views. So on this thing, on my little parts, let's see if I can find an example. Oh yeah, up here. If you look up here, look at all these parts. These parts are actually stuck on the inside of the doors of these little compartments. So before, like if I wanted to open the 249 ohm, for example, I'm just in the habit of going like that, and it knocks off all the parts in that sections. And then when you open it, the parts are in the bottom, and they're not all stuck up in here, and they don't come out and go where they shouldn't. What am I looking for now? Okay, so I am going to, where did it go? Let's see if the other protection, oh there it is, okay. So one of the things that I've run out of is these little PGBT 101s, I think they are, which are static protection chips. There you see it. And it's a Zener. It's like they're not polarized, because it's basically like two Zeners back to back, I think internally is the way they work. And they're used for protection on USB data lines. And you can see these are the two data lines that come in, D plus and D minus, and these just go to ground. And so if there is bad stuff happening on the data lines, it helps protect both our device and the upstream device, the computer or whatever it is that we plugged into. Yeah, I haven't been doing too badly, considering I put all these parts on just with my bare eye. They're acceptable. Oh, that part, that is one that I should have lifted off a board and didn't. Alright, so what parts are going on here? We've got a couple of 10Ks and a 100 nanofarad. So, where are we? Right there. And another 10K right there. I'm going to need to grab myself another one of these 10K resistor arrays. Do I have any lying around on the pick and place machine? Which is quite possible. Nope, and there isn't one in the discard bin. So I will pull one out of a feeder. And it is, got to check which feeder it is. 10K 0.1%, that one. Here we go. Since I'm making such slow progress on this, I'm beginning to think I should have gone to the trouble of setting up the pick and place machine. Other way. All right, where are we going with this one? Right there. Come on. I hate it when that happens. These tweezers are not perfectly clean. They've got a little bit of flux or something on them, so they're slightly sticky. Which means that sometimes when I try to put parts down, the part doesn't want to stay down. What I should do is change it so that it's switching between microscope view and desktop view. That would be more useful in this situation. What else have we got? 10K, we've got 1K, done that. Oh, 49 R9s. Did I put all of those on? Yes, I did. There's a 1K up there. Got to put that on. How to spend a Friday evening. Just for the fun of it, I'm going to look for my my weird and wonderful color pack of LEDs. Probably in the other LEDs section. Yes, here it is. So here I have a little sample pack of miscellaneous LED colors. Let's see what we've got. Could just put different ones on as a mystery and see what comes out. What's this? UV. They're ultraviolet LEDs. Oh, what's that? Why? That's just yellow. There's only one left. Yellow doesn't seem very exciting. Green. I think that is a special green though. There's or is it this one? P. Oh, purple. These ones look really cool. And that one, I don't know what that is. So let's put some on. And what's this one? Don't know what that one is either. Looks like there's some writing on it, but I might be able to see it better under here. Which way does it go? Oh! I have a feeling these ones are orange. Yeah, let's put some orange ones on. And we've definitely got to put on purple. I used to have pink and I used to have jade green. I love the jade green LEDs. Activity. Let's do... what size is that? Oh yeah. Okay, so this is green, but I don't know what sort of green. I don't think it's the jade green. And some of these are in kind of strange packages as well. Now, which way around is it? I think it's from... Oh yeah, that will be 3.3 volts up there, which means the anode goes up. Look at the strange package. So this is a green one on the 100. And... what's this one? Is this the purple one? P, purple. Yes. Let's go for purple on something. Which one should we make purple? Oh, I can't even tell which way around it is. Let's see if there are markings on the bottom. Okay, I'm going to have to get out my little LED tester tweezers. Where did they go? Come on. It's the obscure things that when you want them, you can't find them. Where are my tester tweezers? Can't see them. So I'll just resort to the the old style LED tester, which is not nearly as convenient. Hang on, I'll get this up where you can see it. There. And I'll turn down the current a little bit. Let's just give it 10 milliamps. And I'm going to try to hold that down while I touch the contacts and see if it turns on. And it does not. So I'll turn it around. There we go, purple LED, which means it's oriented now with the anode to the top. So as long as I put it down in the same orientation on the board, we should be good to go. Yeah, I'll make that one activity. UV is no use. Yellow, yeah, let's just use up the last yellow one. And I'll pick it up so that anode is at the top. Yellow, I'll just make that link. And full duplex, let's use, oh, so we've used P. Did we end up using orange? I can't remember. I don't think we've used orange yet. All right. Let's test the orange one, just to see what color it is, see what it comes out as. I think it says O on it. Oh, didn't switch back. The switcher is not 100% reliable. Yeah, orange. I'm looking on the screen there. It looks a little bit more red to you than it does to me. It looks slightly more orange to the eye than it does on the camera. Okay, so now we have our fantastical colored LEDs. I'm going to leave that there for now, break my own rule and leave it messy. Now this part is this is part of the power supply source selection. Where is it? There. That should be an LM358, I believe. I'm not even going to look at Eagle. I trust that that's what it is. Still a bit of rubbish on there. That's a part that I also scavenged off another board. All right. Are we there yet? Nearly? What goes there? Ah, that's one of those dual BJT, like 2 transistors in one package things, I think. Dual, yeah, MMDT 3904, and there's a another kind of equivalent. I think I have some. Where do I have some? Oh yeah, UMH3N is the other type. It's basically a couple of NPN transistors in a SOC23 style package. So you can do the same thing just with 2 separate transistors. But this is smaller and it's only 1 placement with the pick and place machine instead of 2. Same benefit as using something like a resistor network. Now it should not, I don't know why it's actually got markings on it. You can see that there is a pin 1 marking there. They have a symmetrical pin out, so it shouldn't matter. It should not make any difference. I think I'm just going to start putting capacitors down as well since we're in this area. What capacitors do we need? We need So we've got 47.5K that you can see there at the bottom of the screen. We need a 22.1. That's the one that I ran out of, wasn't it? Was it? No, that's right. I did have 22.1s in here. No, I didn't. No, I did not. I must have pulled it out of the machine earlier. Or did I just move right on and forget all about it? That's probably what happened. 22.1. Do I have any reels? Time to take a quick look at the reel situation. Okay. 4K7. I think that I might have a reel of 22K ones up here somewhere. Not in the machine, but just hanging around, providing general ambience to the room. Maybe. Yes, a whole reel sitting here in the box. Woohoo! While I'm at it, I should dispense some of these into the container, but I won't do that right now. What I'll do is cut off a bit of tape. Write on it what it is, because otherwise you can guarantee that I will forget. There'll be this bit of tape lying on the bench. 22K. And when I come back to clean up tomorrow, I won't know what it's for. All right, 22K resistor. Where are you going? Come on. 22K, where are you going? Right there, just above the CP2102N. Right. Right there. Now, what lives beside you? That looks like a capacitor. And it is, it's a 100 nanofarad capacitor. All right, let's just start putting caps down as well. $100 nanofarad. There'll be a bunch of these on the board. Where is this going? Right there. And these two were caps as well. What were they? 22 nanofarad and 10 nanofarad. Well, righty-ho then. 10s. Oh, I've only got these horrible big 0805s. I've got some 0402s I could use. Do I have any in the machine? No. So the question is that a critical value? Do we care? It's a 10 nanofarad pull down on the receive line on the Ethernet. I don't think it's massively critical. So 10 nanofarad, I could put on... Oh, 8.2s are empty as well. Let's... There's a 6.8, but it's in a horrible huge package. What have we got there? 10. Yeah, that'll do. Stuff it. What's it going to do? Stop the Ethernet from working? Possibly. Okay, so 22 nanofarad. Ah, no 0805s. I'm tempted to go for 0402s because I've got plenty of those here. 22 nanofarad is, yeah, let's This is going to look rather ridiculous, but let's just try it. There's an 0402 on an 0603 pad, and down here there's an 0805 on an 0603 pad. Oh well, we might get some bad tombstoning or something, but we can fix it in post. I have not looked at chat for ages. I just saw in the bottom it said, "Are we winning, John?" We're always winning. Yes, Cable Tie says, "Tombstone coming up." Yeah. Oh, there's lots of chat there that I haven't read back through. So, oh, Dana asked a question. What's a good, well-known brand of solder paste, or is it mostly irrelevant? No, it's not irrelevant. And, ooh, Cable Tie says, I'm being a co-host one day. Cool. Yeah, so solder paste. That is a very big subject. In Australia, probably one of the better places to get it from is Chem Tools, who I think are in Sydney, but they sell online. And I hate to say this, but a certain electronics parts chain around Australia sells Chem Tools products. At least they have a subset of Chem Tools solder. So I buy stuff directly from Chem Tools, but you can also sometimes get it from that other place. Right. So what I'm using, although, what have I been using? No, I've been using ChipQuick recently. So the most recent stuff that I've been using is ChipQuick leaded solder, and it's no clean, although I do clean it. And I'm currently using the T4 size. So it's kind of like a medium to small size solder balls. 80, thank you. Thank you. I think we all need a beverage of choice at some point. Now, where are we at with this? Yeah, my auto view changer only works most of the time. I need to do a bit of work on it, but I did only get it going this afternoon very quickly, not long before this. I just saw some mention of solder paste there. So Ian Scott Johnson said, for production I use lead-free GC10 type T4, not cheap. Yeah, so GC is the funny thing is GC actually legitimately stands for game changer, and T4 is the size of the balls in the solder. And as you go for like smaller solder balls, their characteristics change and the solder paste becomes a lot more expensive, like a lot more expensive. By the time you get up to like T5 size, which is very small balls of solder, then yeah, a little tub can be a lot of money. Dana said, okay, if using ChipQuick, check Twitter. I had better check Twitter then. We can verify it. You know, gotta. Okay, thanks, Dana. What am I looking for? That's right, 4.7 microfarad. 4.7. Where are you? 4.7 nanofarad right there. Oh, why do I not have these particular values? All right, I'm going to plonk down a big horrible, where is it? Right there, 0805. Is it 0805? It's a weird size. It's not as, I don't think it's as big as 0805. It's definitely bigger than a normal 0603 part. But it'll fit. All right, so then we need a 10 nanofarad and a 100 nanofarad. Let's go for the 100 because I know I've got those. the 10s I do not believe I have. We've got the same problem again. Hey, let's see if we can get not just tombstones, but see if we can get some solder bridges as well. See if I've got these huge capacitors, which means that we may get some solder bridges happening between them, which would be really cool. It makes the conductivity better when you got solder bridges. And that's only a good thing, right? Now, what else have we got up here? We've got another 100 nanofarad. And we've got an inductor. Okay. I need to be more methodical about how I'm doing this. I need to work through areas of the board. My other strategy of doing all of the parts by value was not a good idea. All right, now, these inductors, where is it? So this. These just arrived, 0805, one, that I believe is the inductors. These arrived today. So this is called a just-in-time supply chain. We're running so lean that the parts arrive hours before we need them. Or I'm just not organized enough. Which is the same thing, right? I can pretend I'm Toyota. I can't even pick this thing up to get the tape off it. These are weird looking things. I've never actually ordered this part before. Like I've used, oh wow, it's a proper wire wound. Oh, that's cool. Look at this. You can see through the top. It's a proper wire wound inductor. Nice. The footprint is not quite not quite right for what I've got there on the board. But that's okay. Now what's up there? Probably another 100 nanofarad. Yes it is. Yeah, there's a 100 nanofarad down near the SD card slot that is in a kind of unfortunate place. It's not where I wanted it to be, but it ended up having to be there because there wasn't really any better place to put it. 100 nanofarad, okay, so that goes there, and then we want a 10 nanofarad on there. To 10? No, 10 nanofarad, yes. So 10 nanofarad. Let's go for a big old oversized capacitor again. Novelty size. Ooh, look at this. Something doesn't quite match. All right, who's sending me messages? Iggy. Yes. Hey, Iggy just sent me a message saying that it keeps jumping between the microscope and the parts tray. Yes. That was kind of intentional, but it's not quite working out how I expected. Yes. So, yeah. What was that comment? Cable Tie said, I learned something today, that Dalton SA exists and where it is. Okay. Sion, cool. I'm Peter and Chris. lots of people have joined. Yeah, all right, Iggy. So if you weren't here at the start, you might have missed the thing that I thought was clever, and it might end up just being. Sion just sent me a message saying sending you a message too, and that was all I could read. So there is an ultrasonic sensor on the front of the microscope. So no hands. I move to the microscope, and you should get the microscope view. And did it work? I can't actually tell. No, it's not changing. My changer has stopped. Hang on, I got to change back to... Yeah, that's better. Okay. I think it was just like a focus thing. So, as in focus on the computer. So if I look at the microscope, you get the microscope view, and I move my head away, and you get the bench view. All right, back to putting parts on this board, because that's kind of what we're here for, isn't it? What else am I missing? I need the... I need this, which is the 500 milliamp polyfuse. Stick that on. I'm avoiding the pieces around the edge of the board just for now because I might bump them. Connectors will go on just about last. What is that one? There's probably another capacitor, which is why I ignored it earlier when I was in this region. 1 microfarad. Let's see if we've got any 1 microfarad caps. 1. Oh, amazing. 1 microfarad. I actually have in the correct size. While I'm here, I'm just going to stick that CP2102N on there. And I am temporarily rich in CP2102Ns. I ordered the last 57, I think it was, that DigiKey had in stock, and I ordered some from somewhere else, LCSC, I think. Oh no, it was the last 37, right there. Just arrived today, once again, just in time stock management. So the last 37 that DigiKey had in stock, and then I also ordered a bunch from LCSC. And I think I see, oh, I opened the wrong bag, that's why. That's the, that is CPs, but it's not the QFN. What am I looking at here? 20, is this the right size? That would be, am I even looking in the right bag? Which ones do I want? QFN 24 or QFN 20? I can't remember. That would be funny if I had the wrong ones here. I think I've got yeah, they're the 24s. I want a no, not that. I want a, yeah, it is a QFN 24. Then why does it look wrong? Maybe it's just because my eyes need calibration. If I get it out of the package, it'll probably turn out to be the right thing. Probably looks bigger. It looks like it's a QFN 28 when I look at it in the tape. And which way around does that go? Pin 1 is down there. Okay. So it goes that way. Oh yeah, it is right. Kaplonk. I will see you later, little guy, for some rework, because I know you're going to fail. Okay, so then... Now, caps on... Now that one, I think, is going to be a 25 megahertz crystal, if I remember correctly. Oops. Because that'll be the crystal for the WizNet chip. Better stuff all this back in the bag or I'm going to get everything confused later. Now that I know those are the QFN24s, and that is correct, they can go back in the ICs box. Then I want, what was I just saying I wanted? Like 30 seconds ago. I said I need something, and now I can't remember what it was. I need... that's right, crystals. 25 megahertz crystals. I have those over here. I am 90% sure. Yes, now I'm 100% sure. You know, I'm using up all of my chattiness in this live stream. I spend all day basically sitting in total silence and just focused, not talking to anyone. And even when I am around people, I generally don't say very much. So, being on a live stream and chatting like this is quite alien. Now, what caps do we put? What are the loading caps on that 18 picofarad on that crystal? Do I have 18 picofarad? Do I? Not there, I don't. Oh, I've got some 15s. We're gonna take a punt. Ooh, it's a risk. I'm gonna put 15s on. Okay. Do I have 18s in a reel? I might. In fact, I suspect that I do. Let's see. Not in the machine, but I think I might have a reel of 18s somewhere else. And I should probably try to get that right. Because if that crystal does not resonate, we have no Ethernet. And then we're unhappy. No. Can't see them. Oh well. 15 nanofarad it is. 15 picofarad rather. At least I hope it's 15 picofarad. Alright, so what other part of the board here? Okay, so we got some 10 nanofarads, there's the 3.3 volt regulator, there's another 10k resistor. $10Ks, the universal resistor. And I need some 10 microfarads. And these ones actually are intended to be 0805s. It's got the footprint there for it. Got another 10. I hate grabbing parts on the ends like this because you end up getting the tweezers in the solder paste. And then they get sticky like that. What's that one? That one is 100 nanofarad, of course, because all capacitors are 100 nanofarad, except for the ones that aren't. There aren't many of those. There's a little bit of hair there. Okay, that'll be the AP2112K voltage regulator. And I'm going to swap one of those out of the pick and place machine. Here we go. Yes, I really am thinking that I should have loaded this job into the machine, even for one board. Alright, so what goes there? Oh, that's an SS56. That'll be a... where are my SS56s? I think I've got a little container up here. Oh, and SS14 does the same thing, I believe. Should just be a Schottky. Let's see, do I have them over here though? Oh, I've got them over there, so I'll use the proper thing, just in case the specs on the SS14 aren't quite the same. What that is doing is providing polarity protection on the power input on the back of the board. And it's just a Schottky diode rated to some surprisingly large number of amps, like 6 or something, in a little SMA package. What have we got? What else do we have here? Oh, there's another one there, and we've mostly worked around the board. It's sorry, my brain is all over the place. Yeah, we've mostly worked around the board. It's been a bit of stuffing around, and I have not been in efficiency mode, that's for sure. But we're getting to the point where it's the big stuff left to put on. All right, we've got power LED that goes up there. Power LED, let's just be boring and make it blue. Got some right here. Got to pick it up the right way around here. Anode at the bottom. Yep. Burp. These are really old LEDs. Look at the discoloration on the pads. It's horrible. Shouldn't be using them anymore. But that's what I've got loose in my little pack of stuff. And was a 4K7. We could probably go a higher value. What's it running off? 3.3 volts. I could put a 6K8 or something on there. 4K7 with a blue LED tends to look very bright. 4.7. Let's just put a 5K resistor on that. So there's a reset button. Need one of those. What's down there? Oh, there's the little 100 nanofarad cap hanging in the middle of nowhere. That's the one I was talking about earlier. That is supposed to be power supply decoupling for the SD card, but the 3.3 volt rail going to the SD card does not have a direct path on the top of the board, so it goes down through a via and then one of these. Don't know which one. One of those is the 3.3 volt connection. What's there? Oh, temperature sensor. Okay, let's grab one of those. That's the MCP9808. Yeah, just lots of rustling. Oh, come on. I should be doing these sorts of things where you can see it. Oh, I'm just trying to get the cover tape off this little cut off bit of stuff. So, and yes, just because I know that Iggy is around, this entire bench surface is static dissipative with the bottom layer connected to ground. So dumping stuff down on here is okay. It's not going to zap it in a nasty way. I think we might be almost done for little parts. Apart from, there is a, oh, what's that? Apart from that transistor, that's what I was going to talk about. But what is that part right there? It'll be a capacitor, of course, but what is it? 100 nanofarad. What a surprise. So that little part of the circuit, this part here, is part of the power supply auto switch. This is a dual op amp, and what it does is check whether you've got power from USB and from external power, and it prioritizes the external power over the USB, just the way it's done on an Arduino. Now that right there is it is a transistor, and what I should have done was swiped one of those transistors off one of the other boards when I was stripping them, because I do not think I have that specific transistor. What is it, an FDN340P? That's one of the parts that I've ordered but has not yet arrived, so I need to strip it off another board. Unless I do happen to have some in my... Oh, what? I have some. Fantastic. I have a little off-cut strip of them. Present me, thanks past me. It saves me getting out the board preheater and the hot air and flowing one off a trashed board. Has everybody gone home yet? Or are you still hanging around to see what happens? Looks like a few people are still hanging around. Alright. There's the WizNet chip. Yeah, it's at the point where I should just start sticking on these big things, the exotic parts. We're past all the jelly bean bits. Where is it? Oh, there's W6100s. No W5500s there. I think I've got some in a container up here. That's right. I even pulled these out on the live stream recently. And I also have, ta-da, arrived today, 100 W5500s. So we'll be okay for the foreseeable future. W5500. I need to file these in a better place instead of just having them there. All right, 5500. Did I get the footprint correct? I hope so. There are lots of things I hope I got correct about this. This is one of those times I go for the old curved tweezers, which I normally don't like. Like, I don't generally use them, but this particular package, which you can't see because it's slightly out of the field of view, this particular package, it really lends itself to the right angled tweezers. Pin one down there. I'm going to slide it around a bit to smear the solder paste. Come on, solder paste. There we go. This is almost certainly going to need some rework once it's been through the oven. Now, What else? Okay, we need USB. I need a Room 32 module. We need the micro SD card. Room 32s, where are they? They're in a box hiding down here. The tape on these is huge. Throwing parts on the floor now. Don't tell Iggy. Okay, those can go back in here. All right, just going to plonk this down by hand, get it in about the right place, smush it around. Looks close enough for government work. And then the micro SD card. This is where I hope that I actually used the right footprint. Did I? Didn't I? Because this is it's a salvaged part. Does it look correct? Yeah, those pads line up. That looks like it lines up. All right. We'll put it in place. Looks like the contacts line up. Yeah, good. I did use the right footprint. We need a couple of big caps, and then we are just about ready for reflow. The USB-C. Okay, so I need 2 large caps, like 330 microfarad decoupling caps, which I have back over here out of view. And then I need USB-C, and then it's time to start up the reflow oven. Oh, and the big chunky through-hole voltage regulator. I need to stick that on as well. In fact, I'm going to do that before I put on the caps, because these big electrolytic caps tend to be unstable. They're a fair bit of mass and they can come off, and that might happen while I'm moving things around. So I'm going to do the voltage regulator next, because that will be very stable. And then I'll do the USB-C connector and the 2 caps, and then if anyone can see anything that's missing off the board, don't tell me, because I want to live in blissful ignorance and imagine that I'm nearly done. Voltage regulator, that's it. And what do we want? We want the 5 volt, Russell, industrial grade 5 volt. Not industrial grade, automotive grade. That's what I'm trying to say. Now this whole regulator thing, this is open to revision. We might change this. So what I've put on the board is the footprint for one of these. It's just the classic 7805 type linear regulator, but it's the ones I like to get are the special automotive grade ones, which are a lot more expensive than your regular 7805, but they have really good specs for temperature range and also for durability. Like they can withstand load dumps coming off the alternator, and so a load dump is when you have the car running, and I'm going to check this under the microscope just to make sure I did a reasonable job of that. So you've got the car running, engine is spinning, alternator is generating power, and you are drawing that power in some way, like you might have high beam lights on or something, and there is a sudden decrease, stick on there, in the current consumption of something in the car. I'm describing this really badly, but oh well. And the alternator will continue, you can think of it kind of like momentum. It'll continue to deliver power briefly, and the voltage on the electrical system of the car can spike very dramatically. So you might have a car that's running at a nominal 14.7 volts or something while it's charging off the alternator, and then you turn off your high beams or something else happens in the car, and all of a sudden the car electrical system jumps to 60 volts or, you know, some crazy thing like that. Only briefly, but it happens a lot, and car electrical systems are really, really bad. They're really noisy, and so for something to survive in a car electrical system long term, it's got to be really durable. And the voltage regulators that are designed for automotive use are designed to withstand all sorts of crap. All right, so we've got, what am I missing? I've got to be missing parts. I don't think I am missing parts. It's a miracle. All right, now I don't have my remote camera set up, like the portable camera. So what I'm going to do is just chuck this in the reflow oven, but you're not going to get to see it. I've shown the reflow oven before anyway. It's not that exciting. So I need lights, I need ventilation, I need power. I'm just going to chuck this in the oven and leave it here for a little while and then come back and talk to you. So what have we got? I've got to select the profile. So I'm going to go for, okay, profile, exit, and start. Go ski. All right. So the reflow oven is doing its thing. So in the meantime, I'll chuck some of this mess that I've made back out of the way. Clean as you go, clean as you go. Don't leave the mess for later. And while I'm doing this, you can all be thinking about what projects you want to build with the Universal Rack Controller. That goes in there. That will go back in the fridge in a minute. Those are the 22Ks that I labelled earlier, so I would remember what they were. All right. Now, hello everybody. Let's see what you're all up to. Okay. Good enough for Australia. Yep. All right. He says, am I saying that you're an ESD troll? Well, aren't you the one that said that you're... Hang on. There we go. Now I'm okay. Aren't you the one that said that you're an ESD troll? I thought you were. I thought that was like a self-applied title. Yeah, Fred Flintstone's right. I have a wireless one on my ankle where you can't see it. Like wireless ESD strap on one side and the, what do they call it? You know, those tracking devices on the other. So I can't leave home. Yeah. Oh. Okay, now I can relax. Oh, Ilix, due to time zone differences and summer time shifts, the usual Sunday live stream is at 2 a.m. for me, which that's a terrible time. Yeah. All right. Ecognito 3. Yes, it's Sunday morning. Nothing has changed since the 90s. I don't know what that's about. All right. So, I'm not going to bother... 5-volt 40... I'm not going to bother reading back through all of the chat. I'm sorry. So if I've missed things that you've been talking about... How long have I been streaming? Probably about 3 or 4 hours, I'd say, by now. I have been streaming for... What is it? It's a bit after 10. 10:18. It's been a while. It's taken quite a while to just to put some parts on a board. All right, so John says put a SICK 450 on it. 5 volts, 40 amps, chance of fire. I hope there's a good chance of fire. I'd be counting on it. So the SICK 450, SICK SIC 450, that's the one that you're using for Sarah's tapestry project, I think. Is that right? So for those of you who don't know, John's wife Sarah has made a crazy tapestry, which is the it's the sky, and it's got constellations and things on it. It looks incredible, and they are wiring them up with LEDs so that it's yeah, so that it is, they can illuminate different things. But that's a lot of LEDs to illuminate and takes a lot of power. So John's been working on power supply modules. Yep. Cable Tie says, try designing something that runs nominally on 24 volts and has to survive 6 volts cracking. I assume that's cranking. Yeah, that is a problem. That's the opposite problem. So if you've got a device in a car or a truck, 24 volts, which means it's probably in a truck, because truck electrical systems are typically 24 volts, which is why the... which way do I go? That way. The water cannon of doom runs on 24 volts. It can run on 12 volts, but most often on 24 volts. And when the engine is cranking, the voltage drops from the nominal 12 or 24 down to only a few volts. So having something that runs off a 24 volt supply and can handle the input voltage dropping to 6, yeah, that's not fun. So Russell Smith said, is there an alternative to RJ45 to avoid AU cabling restrictions? That's an interesting question. So as an alternative, the reason that I ended up going for, well, it's interesting for 2 reasons. One is legislation. So what that comment would be related to is whether you can put in your own Cat5 cabling, and it's kind of a curly one that I don't want to get into right now. The other, oh, that side camera keeps moving. The other is the reason that I did it, the reason that I've actually used essentially Ethernet cable for my light switch controller is because my light switches originally were Ethernet. I actually had an Arduino behind each light switch with Ethernet on it, and that's why the Ether10 was designed way back 12 years ago, 11 years ago, whatever it was. It was because I had an Arduino and an Ethernet shield jammed together behind every light switch in my house, and they were all on Ethernet, running power over Ethernet. And then the Ether10 was basically an Arduino Uno and an Ethernet shield, and you put them under a steamroller, squash them into a single PCB, and that's what you get. So I had Ether10s in most of my light switches, and I ended up switching over from having the complexity in the switch to having the complexity in the controller, all of my cabling was still in place. So I just made the new light switches work over Ethernet cable, even though it's no longer Ethernet. So the reason it's like that is kind of for historical reasons. Ooh, I've just heard the note change on the cooling fan on the reflow oven, which means it's just hit its peak and it's now on the cool down part of the cycle. And so, so that's the historical reason that I did it, and also just because Cat5 is cheap, the connectors are cheap, etc. But is there an alternative? You could wire it with something different, but I don't know that's necessarily going to solve the problem. It's not going to avoid the issue of, can you legally put in the cabling? Yeah. Cable Tie says, automotive PSUs are the worst to design, except for truck and large vehicle 24 volt PSUs, which are the worst too. Yeah. Funny story. I'm working on 2 truck projects at the moment. No, that was not a funny story. Well, that's a truck project. There's another project I've been working on for a while now, which I have never mentioned on a live stream, and I'm not going to until it's actually in the market. But it's a really interesting project, which is also truck related. It's a robotic sort of automation system related to trucks. But that's all I'm going to tell you. I'm just going to go and pull the door open a little bit on this oven, which improves the airflow through it. And that's a really cool project, and I want to be able to talk about it, but I can't yet. It's a commercial thing for a client who is also a very old friend of mine, and I do not want to do anything that's going to jeopardize it. So AJ Sortel said, what are you building? Okay, what we are doing is assembling the prototype for the Universal Rack Controller project, and just wondering how much to backtrack in the explanation. Maybe the explanation will come once I pull the thing out of the oven and we see what happens. Yeah. David said, when's lunch? You being Peter. It's Peter's job to tell me to stop for lunch. And it's not time yet. Alright. It's almost time for me to go and grab that thing out of the oven. So, oh, John Spencer said, we are soldering the damn thing right now. Yeah, so that's referring to the huge tapestry that Sarah made. We've done about 250, about 600 to go. That's a lot of soldering, a lot of LEDs. WM6H said, sorry, I missed which reflow oven you're using. I've got a T962C, I think is the model. Looks like this camera isn't focusing properly. Oh, there's the beep of doom. And this is the point where I do everything in my power to resist the urge to pick up the PCB. So what I'm going to do is grab my trusty piece of wood and some pliers and get the PCB. Maybe if I can find somewhere to pick it up from a corner somewhere. Come on. All right. One freshly baked PCB. And of course, we all want to see what it's like, so let's do a magic camera switch. Come on, switch back. It switched there, and then it failed to switch back. I got to try putting OBS in the foreground again. Let's try it again. Will it switch? Yes, now it's switched. All right, gotta try not to burn myself. Toasty hot. All right. Still got some connectors that have got to go on here. But before doing that, it's going to be a bit of a visual inspection time. So let's see if we can find all of those tombstones and things. Okay. Time to go hunting. See if we can find any clickers or shamblers. What have we got? Should try to be methodical about this. Okay, I'll start from the top right corner. That's a bit of damage from when I just picked it up with the pliers. So from the top right corner, that looks alright. Oh, look at this. They're all sitting nicely in place. Our weird, it's like a Rogues Gallery LED collection. They're all different and mostly weird. Alright, we've got a bridge there to fix, and looks like we're a little bit short on solder there. Is that, yeah, it's not actually soldered. That's alright, we can fix that. Alright, everybody mute your she who shall not be named, because I'm about to say, alright, this will be a test. Let's see whose house this works in. Alexa, please turn on the soldering iron. Alrighty, so give it a minute and the iron will be hot. Oh, lots of solder bridges there. We can fix those. Looking okay. Ooh, it's a bit of crud in it. Looking fine around the room 32. Up here. Ooh. Bonus extra solder, spare solder ball. I'll save that for later. Steve survived the reflow oven. Those are okay. Orientation is okay on that, I think. Yes, I got it the right way around, so I'll add some solder to these pads. I put solder paste on this, as you might have noticed, before I put it through the oven. That's kind of just to tack it in place. And there was solder paste on the large thermal pad, of course. But I will manually supplement that. Now, this is an area where if there are solder bridges, it's a real problem. In here, because fixing stuff in here is a total pain. But luckily, it looks like there are no bridges in there. So that's good. Got our SD card attached. There's the temperature sensor. No solder bridges there. So we need to do a little bit of rework around the Ethernet chip, which I fully expected. We've got to do a bit of rework around the back of the USB-C connector. Now right there you can see that there is a pad that looks a bit shiny and it may not be properly connected. And right there, oh, that one looks alright. Without a proper 3D view, it's hard to tell. So, let's do this thing. Start by applying some Make It Work juice. Blah, blah, blah. I could reflow this, but I'm just going to do it with the iron, I think. Do a bit of a drag. I've got too much in there. Oh no, that came out okay. Doesn't look like there are any shorts there. It's all clear. Now back to this side. Oh, that pin looks bent. That pin is bent. That's bizarre. It must have been bent like that when I put it on the board. Alright, let's do a drag. Come on, get that one off. Nope. Alright. Bring in the big guns. Hit it with a bit of solder wick. That'll clean it right up. And Yeah, see, this pin is bent. Let's see if we can... Oh, it's adhered to the pad. Not anymore. I broke it loose. Looks like a ground pin. It's connected through to the ground plane. Alright, what do I want? Solder. When do I want it? Right now. Just a little bit. There. Now, what do we have on this side? Any bridges? Oh yes, there's one there. I put the, oh, in there. Fix all those up. Done, I think. And back over here. What have we got going on this side? Just dodgy joints. There, fixed. Alright, so let's have a look at this one. Put some of the Magic Make It Good juice under there, the back of the USB-C connector. And I may not be able to do just the simple drag trick with this. It might work, but probably won't. I find that USB-C connectors, reworking the back of them is a bit of a pain. Yeah, that looks alright. I think we just removed 3 solder bridges then. Oh no, there's solder bridge there between ground and VCC or VN. Looks alright. Okay. However, I've got to get a different angle on this. So often if you look down into the back of the USB-C connector like this, you'll see that there are solder bridges between pins down under the plastic where you can't even see them. But that one looks alright. So that one's all sorted. Now, are we going to do anything about this? Well, let's just see if we can get a better angle on that pad. Don't know if I can be bothered reworking it unless it looks like... Oh, it does look suspicious. If you can see the pad I mean, it is this... Where's my pointer? This one right there. That pad looks like it may not be connected, and it is actually a pad that matters. So, for this one, let's use the hot air. We'll put the magic juice on it and heat it up and bring it up here. All right. Oh, since there were questions about solder paste earlier, I'm using Chip Quick tack flux. So, good stuff. All right, let's cook this. Well, there's a resistor just above it, the 22K resistor, just slightly above it, which is out of position. That will probably end up reflowing into position properly if I warm all of this up enough. Once we start seeing some bubbles coming out of the flux, when the flux has got to just on the boiling point, that's usually when things are good to go. Is anything else moving? No. Come on. A little bit more warmth. Oh, there we go. As you can see, this one's moving around. Which means this one will probably move around as well. There's a big thermal pad under it, so it takes a little while to warm up. And that is where the solder flux really helps. Oh, there's the pad. Alright. Let's just... Oh, that's not going to work. Oh, come on. Surface tension working against me there. I've got to get surface tension working for me. It's, I think it's about there. That's about where it needs to be. And then we should have some decent connections on everything. Oh, and in doing that, I've bumped this other resistor. Did I bump that, or was that out of place? Don't know. Anyway, big pool of molten and now congealing flux. Is there anything else here that we need to fix before we can do a very tentative power up? I'm going to do a power up before. It really doesn't look like that's soldered on at this end, but I think it is. I'm going to do a very tentative power up before putting more parts on. Just in case things do need reworking, it's easier when we don't have extra connectors and things around the place. But I will solder these joints first before we do much more. Where did my solder go? Got a little bit of it here. Keep some good heat on it, and the middle one in particular, because there's lots of thermal mass. Now, one of the reasons that I actually don't mind putting through-hole regulators in jobs like this is that the pins form a fantastic high current path between all the layers of the board. So these regulators are available in a surface mount version. Yeah, you can see the middle one, because of the thermal mass, it hasn't really flowed properly through to this side. Yeah, so I'm just going to sit the heat on that middle pin for a minute, let it sit there and cook slowly, let the heat flow through to the other side. Alright. Yeah, so you can get these regulators in a surface mount type, which means that it just goes into pads on the top layer, and then to get power through to the other layers, of course, you use vias, or vias, depends on which continent you're on. And yeah, but I kind of like using these because we've got the legs of the voltage regulator going all the way through the board and connecting to all the intermediate layers as well where necessary, and providing a very good high current path and also a good thermal path between the layers of the board. So yeah, vias are good too, but a nice big pin does the job even better. That board looks a bit of a mess, but it's going to go in the ultrasonic bath later once it's had some testing, so that should get rid of all the discoloration. And we've got the mess over here from the flux that I stuck on. Now let's try powering this up, and what am I going to do it on? Do I have... I'm just trying, the reason I'm pausing is I'm trying to work out a way that you can see the useful things. What I need is a USB. I need to get power to that. Thinking about what I'm doing here. Okay, I can use this, I think. I'll use this USB extension, which means I should be able to... Yes, okay. 4.15 volts, that's pathetic. Okay, so there's a USB tester. It's probably because it's on the end of a 5-meter USB cable and plugged into a hub which is unpowered. So we got lots of voltage drop along the way. So let's get ourselves a USB cable. Moment of truth. What do we have here? Ooh. Just for funkiness, let's use a nice Rode USB-C cable. And okay, when powering up boards like this, so what I'm going to do, just to explain, I'm going to connect power to the USB connection. It might light up, it might not. We'll be able to see on here if it's pulling excessive current, And what I will do when powering up this part of the regulator, so powering up the power supply on this side, is I'll connect it to the bench power supply and I'll set the current limit so that we don't get smoke let out if there is anything wrong. So let's see, power it up, and I will be surprised if it works. Oh, what? Hang on. So far it's working. As in, we've got power up here, so that's showing that we've got a 3.3 volt rail. We've got our USB voltage has dropped, so that's not ideal. We're feeding at 3.39 volts when we should be feeding at 5 volts, but no smoke has come out. So I think the next thing to do is try connecting in fact, I'm going to put a screw terminal on there, I think, because I don't want to solder, where is it? Pluggable screw terminals, that's what I want. Because I don't want to solder pads onto, I'm just going to turn off that reflow oven. It's sitting there spinning its fan. You may not have been able to hear it very clearly, but I could, and it was annoying. So, pluggable terminal box. I want to, oh no, they haven't, those ones haven't arrived yet. Ah, damn. What I want is right angle. Oh, maybe I can just bend this. I'll turn, which way does that go normally? I don't know. Is it normal to put it, to make it that way? I'd have to look at the 3D model to figure out which way is which. I think, so that's positive and that's negative. All right. I don't. And I can't launch Fusion 360 because I got OBS running and it's going to freak out. All right. Let's. Hang on. Even before doing that, let's just try talking to the ESP8266. Yes, I wonder if we even have... Oh, Stephen W is saying the bumpy bits to the regulator side. So by bumpy bits, do you mean these bits and those bits? I think the bumpy bit is, why isn't that focused? Yeah, the bumpy bit is there, which means if this was done as a right angle connector, like it would go in that way, and then as a right angle connector, it would just lean over like that and sit down on the board. And then this would go in, yeah, with the screws up. That makes sense. Okay, cool. That helps clarify it. I will put it, I think I'll put it on like that. But just before I do that, I'm going to, let's just try talking to the ESP32. We might get super lucky and actually be able to talk to it. Oh, that is such a messy looking board with the, it's just this stuff on here that annoys me, and the stickiness and blah. Oh well. It'll be nice and shiny and clean once it's had an ultrasonic bath and a manicure. So what I'm looking for is, let's look for examples, communication, ASCII table. That'll do. That's a reasonable sort of thing to try. Do we even have a port? It's debug console. Let's just see if it's even appearing on my computer. Port 21440, is that it? I'm going to unplug that and see what goes away. I've got too many devices plugged in. yeah, that was it, 21440. So it is actually enumerating. It's coming up on my computer as a serial port. Hang on, but yeah, so this has got a CP2102N on it, which means the first thing we would need to do, no, I know what I need to do. I need to get my laptop. Is my laptop here? No, my laptop is inside the house because I have not actually flashed that. Yes, you're. The reason it is current limiting to 100 milliamps is the setting on the CP2102N. I haven't reconfigured it to ask for 500 milliamps. All right, so let's just. So the auto reset's not going to work. None of the configuration is done in this chip. To reconfigure that, I need Simplicity Studio, which is on my laptop, which is inside the house. So I think I will go and get that in a minute. But first, I'm going to disconnect that. Oh, if it will allow itself to be disconnected. But it was a good sign that it was enumerating on my computer. It was coming up as a valid serial port. So now I'm going to solder this on and do it in a kind of dodgified way. Use a couple of lead offcuts. What have I got? Yes, how am I going to do this in a neat way? There may not be a neat way. But what I want to be able to do is connect my lab power supply on here. I think I'm just going to do it like this, which is a little bit dodgy. But dodgy are us. One there. Put the other one in here. Burn myself for, I don't know, for posterity. Add another scar to the collection. Alright, so knobbly bit's up, you say. I'm going to put it, yeah, I'll put it there. That should do. Join that. Need to re-blobify it. Come on. Get some solder happening in there. Get some more solder happening in there. Give it a second to solidify. Well, that is far less of a dodgy job than I thought it was going to be. Looks almost respectable. Don't tell anyone. That'll be our secret. Okay, so now I want some, I just want a couple of jumper wires. What have I got? What have I got? Oh, come on. I've got to have something in this. I've got lots and lots of jumper wires, just this is my little local cache. I'm looking for some that are pin to pin. I'll just use these ones. I was trying to avoid using those because it's 3 of them attached to each other, but it doesn't matter. All right, what have we got here? We have positive to the bottom. Let's go, purple is positive and gray is negative. Need a smaller screwdriver. Well, this one fit. Will it? Not quite. All right, let's go for a baby size screwdriver. Oh, and the other thing I need to do is, because these are proper raising bale screw terminals, I need to open the bale before I put in the wire. Ah. Am I talking to myself now? Probably. All right, so purple is positive and grey is negative. Let's power up the bench supply. Get myself a cable. Which am I using? Supply 2. Power supply 2, which is currently set for 5 volts and 1 amp, which is approximately the opposite of what I want. So ground and positive. Now this is when we need Aaron's awesome little multimeter display thing. Alright, then I'll get that. Let's just common up the ground connection. Alright, so what are we looking for? Volts. Let's chuck in VSET 12 and I'll do ISET 0.2. So 200 milliamps and turn it on and watch the smoke come out. Where's the smoke? I thought there'd be smoke. Didn't someone promise there'd be smoke? We've got an LED that's on. All right, so on the input side, unfortunately you can't see this, we've got 11.55 volts. On the output side, we've got 5.068 volts. On the 3.3 volt rail, which is right there, we have nothing. Oh no, that's the ground. I was probing the wrong thing. No wonder there's nothing. There better be nothing. 3.309 volts on the 3.3 volt rail. Okay, so our voltage regulators aren't freaking out, which is a good sign. Could pull out the thermal camera and see if there's anything hot, but that's premature. All right, so far we haven't managed to let any smoke out. We've got, oh, let's just check on there, 3.3 volts on there. This is where the LED goes to the front panel. What's going on? Why is this working? 3.3 volts on there. Yep, 3.3. Somebody, like, find a problem. There's got to be a problem. I think the next step is for me to go inside the house and grab my laptop so that we can change the settings on this serial chip, and then we can talk to the ESP32. And if we can talk to the ESP32, I'll put the other headers on. And then apart from doing some software stuff, we're kind of done. All right, now, can I mute myself? All right, can I trust you all? Oh, Kevin, I just looked over. €5, Daishi Soldering for the win, yes. Okay. Red, not orange fizz. All right, wait until we try PoE. Yes, we will do that. In fact, we can try that even tonight with the bypassed PoE once I get the connector, once I get that connector on. Now, can I trust all of you kids not to burn the place down while I go inside the house and grab my laptop? I am going to mute myself because I'm wearing a radio mic right now, and when I walk inside, yes, there will be noise. So I'm going to hit mute and I will be back in just a moment. And in the meantime, you can stare at that and see if you can find where the smoke should be coming out. back. Now, bang. Nobody hide my soldering iron. Okay, so laptop starting up. Just making sure that there are no cameras pointing at my keyboard as I type my password. It's hard here. I am surrounded by cameras. They're all over the place. All right, Simplicity Studio. Simplicity Studio sucks. I really wish there was a simple way to just load configs into Scilab's USB chips without going through Simplicity Studio. All right, now get all of that disconnected while Simplicity Studio is launching. I can feel the voltage regulator was getting warm, like just barely warm. So I was running it on 12 volts and that's regulating it down to 5 so that we've got a 5-volt rail available. And also it then feeds into the 3.3 volt regulator. No, do not do updates, skip updates. I'm running, on my laptop I'm running Simplicity Studio V4 because V5 just, it destroys the world. So I made the mistake of upgrading to V5 on my old iMac and then was totally unable to load configurations onto USB to serial chips. Luckily my laptop still had the Studio V4 installation on it. I can go there. All right, time for another voice command that may well activate things in your house. You have been warned. Alexa, turn off the office fan.
Okay.
All right, so that turned off the exhaust fan that was running where the reflow oven was. Okay, now you can't see my laptop, but I've got I've got Simplicity Studio open. I've got a standard config that I use, program to device, go. Programming, reset, done, elapsed time, 6 seconds. All right, so this should now be programmed. We've got no TX and RX activity, but that's okay, that's to be expected. Now, next thing is plug the board in, load Arduino, which I have, and what are we going to compile for? Target will just be an ESP32 dev module, and what settings do we want? 460,000. What have we got? QAO 4 megabytes. Got the port selected. USB serial 0001, I think, now that it's been reflashed. I'm going to unplug it because I don't want to try reflashing the wrong device. Yep, that was the one. It was enumerating correctly. Yep. And flash, compile. All right, let's see if we can upload code onto it. We'll tell its little brain to send us some ASCII values. Compiling. Come on. This is the moment of truth. Can it upload? Connecting, uploading. It's uploading. Look at the activity. We had activity LEDs, resetting. I'm opening the serial console. I'm not sure if we actually see anything in the ASCII table. Oh, we do. Check this out. Hang on. I'll just switch you to the desktop view. Okay, so this is what I've just loaded is this test sketch. It's one of the examples in the Arduino IDE. And all it does is open a serial port and then dump out all the ASCII values, because we all love ASCII values. And this is what we just got back out of it. So the Universal Rack Controller is officially alive. Haha, fantastic. Now, next thing. Okay, let's, thanks WM6H. Let's put some connectors on it. Let's put on the, I'm going to put on the Ethernet connector, but first I think I'll put on the little, the connector for the front panel LED, just because it's going to be harder once the Ethernet connector is in place. So I need that, and I need to get, yeah, so I want that. Now, somewhere up here on a shelf, I have stock of the correct Ethernet connectors with the built-in magnetics and everything. Here they are. Let's do let's see if we can do the view switch, and back. All right, so it's my little stash of connectors. These are the hand-run connectors with the built-in everything. So I'll solder this on first, which is the connector for the front panel LED. Now, since I sent this off for fabrication, I've been regretting this design decision of just putting a 2-pin header on here for the front panel LED. I want to replace that with an RGB panel mount LED, because there are a couple of things we can do. Firstly, we can show, sorry, you can't really see what's going on there, but it's not interesting, so it doesn't matter. My original idea was that the front panel LED would only show the fact that there was power and nothing else. So it would have no dependencies, like it wouldn't matter if the CPU wasn't running or anything else. It would just show that there is power to the device. And that's what we've got right now. So the 3.3 volt rail has this little current limiting resistor there, and then you can just have an LED mounted in the front panel, plugged into this. But then I thought, wouldn't it be nice if we had an RGB LED on the front panel, so that we could do things like in a rack where you've got a bunch of units, from the web management interface or a phone app or something, you could tell a unit to identify itself. You know, a lot of servers do that, a lot of rack mount equipment, and have the LED change color or start flashing on the one that you've clicked in your management interface. So we don't have any control over the front panel. Now, of course, we can do that. We've got the LCD, so we can do device identification that way. You can tell one to call out. All right, now let's put on, nope, doesn't go that way, the Ethernet socket. All right, what have we got here? I'm going to just solder the big connectors on like this, and then chuck it under the microscope. Actually, no, I'm going to do this under the microscope, because even for these really big connections, because it shows you something interesting. There are things that you see when you solder under the microscope that you just do not see any other time. Okay, so that is one of the mounting stakes that comes through the board. Now, what I like to watch when I'm soldering under the microscope is you can see the heat flow across the board. Now, I don't know how well it's going to come up on camera, but look, you can see the wet edge of, I'll put that on there. Yeah, that was a very bad example. Let's yep, just checking the alignment of the thing before I irrevocably solder the second metal, like the mounting tab on, yeah, you'll see the wet edge of the solder flow around the joint. Right now it's there, I'm pointing kind of at it, and it's slowly flowing around. Oh, and across here you can see the, you can actually see the heat flowing across the board just by seeing the effect that it has. Now, because of the size of this, this keeps flopping around into a... the edge of the board falls over. I need to prop it with something. Try to keep it flat. There we go. That's better. Okay. So... I don't think you can hear it, but I can hear the magpies outside my window. About this time of night, they always start talking to each other. They just sit there in the trees, chortling away. It's one of those sounds that, for me, it has very strong childhood memories because of going away with my parents. We had a little... they had a place out in the country that we would go to, and I used to wake up to the sound of the magpies in the morning. Looks like it's all done. Those pins probably need chopping off, they stick out a long way. Now, I suspect that, okay, so conjecture here. If we connect in Ethernet into this, I suspect we're not going to get any activity LEDs coming up here because the WISNet chip will not be initialized. But we can hope. All right, so what I'm going to do is, I've got a power over Ethernet injector. Oh, I know, I need to put in 2 more headers. So, what do I use? Maybe I'll use red ones because red signifies power. And then I'll use yellow ones for the I2C pull-ups because yellow signifies a color that isn't red. So let's just stick these 2 in. Where's my solder gone? I almost used it up. I normally just use the solder directly off the reel, but earlier I cut a bit off for some reason, and I've been using up the off-cut piece ever since. But now it's gone. Come on. What is going on there? That joint is not wetting. That one did. And now the blue tack's got hot, and when blue tack gets hot, it turns to mush. Oh, I think that might just be the ground connection, that's why it was wicking all the heat away. I really hope that these PoE modules, the ones that go on here, are going to work out. It'd be nice if this all goes smoothly. I think I need to zoom that overhead camera out just a little bit because it's right on the borderline of being able to focus properly. You can see that I'm only holding this a little bit above the bench and it's not really focusing, but it's focused down here. And I think if I zoomed it out slightly, it would be having a better time of it. All right, what have we got? So, all right, now for this power over Ethernet, what I'm going to do is I'm not going to just feed directly. What I would normally do is grab one of my like I've got 12 volt leads just lying around on the bench. It's got a 2.1mm DC jack on it and plenty of amps available because 12 volts is something that's really commonly used. So I just have those leads lying around, but I want current limiting on this. So I'm going to run this off the bench power supply and feed the bench power supply into the network cable. Luckily, I have leads for that, because this is exactly the sort of thing I've done so many times before. Which means I'm really good at messing it up. So, get everything out of the way so that there's no confusion and I know exactly what I'm looking at. So I've got bench supply is going to go into the injection side of the Ethernet. Then I need an Ethernet cable, and I had one. There was a grey one, but I no longer have it. Where was it? I'm sure I had it right here earlier today. Oh, I think I might have used it. All right, what other Ethernet cables do I have? Okay, I've got a very short one. Oh no, there's one. Okay, this is better. So, Ethernet cable goes in that end. Lab supply is turned off. All right, we're going to plug power in at this end. When I say power, I mean Ethernet. And the PoE bypass is currently not connected, which means nothing will happen. So I need to put some jumpers across those. Yep. Where is it? There. Oh, and there are other things I could have tried exercising as well, like the SD card. We could actually test that quite easily. But for now, let's just see if power over Ethernet gets to where it's meant to be. All right, so I've still got it set to 12 volts. I've got it limited to 200 milliamps. Turn it on, and there is a seriously disappointing lack of smoke. All there is this pesky little blue power LED, which says that it's working. And we're pulling 100 milliamps with a 200 milliamp current limit. It is remarkably looking like everything is working. Okay, I'm still waiting for something to go wrong. Nothing's gone wrong. All right, let's test the SD card. Let's we'll pop that out. Okay, so we've got power over Ethernet, as in DIY power over Ethernet, not 802.3, AT or AF or whatever it is. But still, we've got power over Ethernet. All right, so let's go back to connecting this to the computer. And I'm going to chuck a micro SD card in here. I've got one handy right here. Don't know what's on it. It's probably got a Raspberry Pi image or something. Oof, that sounded crunchy. Yeah, there may actually be big problems with this connector because I reflowed it off another board. Come on, go in and stay in. Feels like the latch isn't working. But we might still be able to test it. I can probably just hold it in. So, oh yeah, that's it. It clipped into place. All right, so what we've got now is the SD card snapped into place. And I'll switch back to desktop. We don't want ASCII table anymore. What do I want? There's an SD example. Open examples. There's an SD example that just gets information about the currently connected SD card. So, SD ESP32, SD test. Let's see what this one does. Connect the SD card as follows. So we need to know what the chip select is. I can't remember. So, but before doing anything else, let's just see if this compiles before I change anything. Just make sure it compiles for ESP32. Alright, so what this is going to do is look for the SD card, tell us what type it is. Oh, it's creating a directory. Well, I don't know what's on this SD card. It might not be formatted for anything useful, which means this might fail. It compiled. Alright, so now I've got to remind myself, what was the pinout for this? Schematic. My brain is fading. What is the time? It's 20 past 11. It really is time to be stopping, but still. Okay, so we've got back up here. SDCS is IO5. Okay, so where is it using that? SS, where is it configuring? List FS, constant name, unit levels. Create read file, write file. Oh, it's got a whole bunch of different helper functions there. Alright, so here we go. SD card. SD card type. SD.begin. What arguments can we send to SD.begin? I assume we can tell it chip select. I haven't used this before. Oh, Chris said, sorry, I have been totally ignoring the chat for probably the last half an hour. And I just glanced across and saw one comment. Chris said, isn't it an idea to have a thermal vision camera on top of your workbench and a small LCD screen hanging on a shelf so you can directly see anything heating up while testing out things for the first time? That would be a really convenient thing to do. I have a thermal camera. It is right here. It's actually like physically in reach, and I can just pull it out and point it at things. I do use it reasonably often, but I don't have it permanently mounted, and I plug it into my laptop and use it that way. But yeah, having it mounted overhead would be kind of handy. I often attach it to things, like to the water cannon. I mount it on a test jig so that it's attached over whatever the device is that I'm testing, and then the device can move around with its test assembly and the thermal camera attached, so it stays in a static position. What am I looking at? That's right, I was talking about SD card. So can we just do SD begin and give it an argument of 5? I don't know. I'm totally guessing here. Was it 5? SDCS is 5. Yeah, that's what we got it wired to in here. What the hell? Let's just try. All it can do is complain to us. I'm too lazy to look up the function signature for begin to see if it does take the chip select as its one and only argument. So if it works, this will be amazing. All right, let's open. Wow, it's working. Check that out. The SD card is working. That, considering that I just totally pulled that out of my ass, that I could pass the chip select pin as the argument to the begin function. I just made that up, I've guessed, and it works. This is amazing. So right now it is, yeah, BCM. This is obviously a Raspberry Pi image. Appending, writing, failed to open file for reading. Okay, so there's something going on there. Renaming file, file renamed. There's something odd. Yeah, Adrian said, this whole stream has to be some kind of success record, right? Yes. Now, what else? The only other thing on the board to test is actual Ethernet communications. Well, and the headers like SPI for the LCD, which I haven't even assembled yet, and I2C for the breakout to the light switch controller or whatever else needs to go in. I haven't put the I2C pull-up headers on there. So what, okay, things we have tested. We have USB, it's working. USB to serial is working. We have power source selection working. So we've powered it from USB. We've powered it from the screw terminal on the back. We've powered it over power over Ethernet. They've all worked. We've communicated with the ESP32, so we know this is working. We've talked to the SD card. We know that's working. Our voltage rails look good, 5 volts and 3.3 volts. And okay, I haven't tested this I/O header. So things we haven't done. We haven't tested, oh, actually there's the onboard temperature sensor. We haven't tested that yet. There's the I2C things here we haven't tested. In fact, what I might do, oh, we haven't tested the Ethernet, which is the most important thing of the whole thing. But that is a slightly bigger job because I haven't even looked into the code of what's required. Although maybe we'll, I don't know. I'll see how long my energy and my enthusiasm lasts and whether everybody decides that it's just time to bail. But I might actually get as far as testing the Ethernet as well. Let's put the pull-ups on for I2C, and then we can test whether the temperature sensor works. Because I'm still waiting for something to fail. Alright, so make that one sit flat. Sit flat. Alright, so now I need some jumpers to put on those. I2C pull-ups. And now we can test the temperature sensor. I just need some code that's going to talk to that. I've used this temperature sensor in quite a few of my other projects, so but what I want to do is look for just a simple example. Now, what is this one? Examples. It is an MCP, where is an example for it? 9808. Okay, here we go. Oh, it's the Adafruit MCP library. All right, 115.200. Let's switch to desktop. So what have we got? This is the test. It's going to, what is it going to do? It's just going to look for it and tell us the temperature. Sounds good to me. Make it so. Engage. Yes, my Padawan. Oh, bit of feature creep there. Ray just said, would have been nice if you were able to change the SD card from the front panel. Yeah, this is something for the audience I actually still have not heard. Oh, yes! We have a temperature sensor. Oh, hang on. No, what I meant was, oh, damn, we don't have any smoke coming out yet. So that temperature is slightly overreading. I'm sure it's not actually 27 degrees right here on the board. but I think they tend to overread by a bit anyway, so I need a bit of calibration. Oh, and you can see the temperature went up. That's just because I put my hand over it. It went up to 29 degrees. In fact, I'm going to stick my finger over the temperature sensor and just hold it for a little bit. You can see it's going up to 31 degrees. What you're seeing scrolling up the screen is you're only seeing the top part of the window. I'll bring it up so you can see the bottom. There we go. So it's now on 31.8 degrees, and then I'll take my hand off it and just let it sit there. And we should see the temperature slowly go down again. 30.5. So Aaron said config backups, large web interface files, etc. That's right. You did actually, it was either you or someone else did actually suggest things like web, like media content for a web interface. So if we've got a web management system running on this device, the SD card could be used for storing images and JavaScript files and whatever else it is that you might want to dish down the wire so the temperature is coming back down again. Yeah, it's definitely not 27.8 degrees in here right now. It's probably a comfortable like 22 or 21 degrees in the room right now. But yeah, temperature sensors do tend to overread. They usually need a few degrees of calibration factor applied to them. Okay, we have had so much success that I am kind of afraid to continue, but I'm just going to take a quick look through what can I find. I don't know if the Ethernet, like just the normal Ethernet library supports sorry, I'm fading out while I look through a list of things. Control sensors, Ethernet, DHCP address printer, that'll do. I've got no idea if this is even going to compile for the ESP32. So let's find out. Let's set this to a sensible baud rate. And what's our chip select? Ethernet.init. I've got to go back to here. Our WISNet chip select is 26. So let's see, Ethernet.begin. Ethernet.init. Okay, so I want, let's, doesn't matter which one, I'm just going to edit one of these anyway. Make that 26. I should plug in Ethernet, shouldn't I? I'm going to take, what am I going to use? Okay, I'm going to leave, I'm going to think about what I'm doing here. I'm going to plug in Ethernet. Let's see if smoke comes out now, because we've got power from two different sources. That's interesting. Yeah, that is not happy. Okay, maybe we've found the first bit of fail on here. What I just did, that you probably could not see, was I had USB plugged in and I had PoE coming down the wire from this, and it was maxing out the current on the PoE. I had the current limiter set, but I wonder if there is some weird interaction between power coming through this way and power from USB, which means that the power source auto select may not be working. That's interesting to know, but it is not something that I'm going to investigate right now. I'm going to file that because first I just want to see if Ethernet does work. So Ethernet disconnected, and let's see, I'll connect Ethernet, but I've turned off the bench supply, like I've turned off its output. So we now have power over USB only, and we have network coming in here. So let's just, does it compile for the ESP32? I think the law says that I have to stop this live stream at some point. Come on. OBS wasn't changing its view. Okay, so it compiled. What the hell? All right, upload. Do it. Let's go. Chris said, are you powering your computer via the PoE? Yes. Yeah, could you not remove the PoE link? Yes, that would be the same thing. But I just pressed the button on the lab power supply. Let's see what's going on here. So, what are we doing? Okay, I've opened that. I'll hit reset. Ethernet could not fail to configure Ethernet using DHCP. Ethernet shield was not found. Okay, now this, I'm not entirely surprised by this because I have a feeling that this library doesn't even work properly with ESP32. But this is not necessarily something for us to figure out today. I'm going to remove the injector, plug that straight into there. There are all sorts of reasons this could have failed. This could be it could be the crystal on the WIZnet chip as well. So there are hardware reasons it could have failed, and there are software reasons it could have failed. But to be honest, I'm tired now. My brain is not up to like a big diagnostic session. So I am going to stop and go and sit down for a little bit, maybe have a drink, and then I'm going to come back to this with a clearer head tomorrow. Probably not on a live stream, but I wonder if it could be power as well. Because I have seen WIZnet chips fail to initialize if you don't give them, like if we've got voltage drop over the USB and we're not giving it all of the little volts that it needs, it might have failed to initialize. So yeah, multiple reasons that it could be. But as I said, I'm kind of burnt out by now. Oh, Adrian, 10. Thank you very much. As Chris says, I'm going to stop and keep going. I wonder why the power... Yes. Yeah, sleep on it. Yeah. Right off the top of my head, I can think of multiple reasons that the Ethernet could be failing right now. It could be as simple as... Here we go. I'm back looking at it. Wiz RST is 13. Wiz interrupt WIZnet chip select is 26. Okay. No. I must resist the urge and come back to this with a clearer head. All right. How long? I've been live streaming for nearly 3 hours. Yes, no wonder I need a rest. So, whew. Thank you everyone. Yes. I keep saying that I'm going to stop, and I really need to just stop. But thank you for coming along. It's been an unusual live stream, but I want to get myself set up a bit better for hands-on sort of things as well. And I've got the zoom control that I'm working on for the overhead camera, so I can zoom in and out just like while I'm down here on the bench. And I've got the auto switcher on the microscope. I also have this, which is a head-mounted camera to give you just the view of whatever I'm looking at. And I've actually got this working, but the latency on it is terrible. it's got like 2 seconds lag on it if I connect you to the RTSP stream over Wi-Fi. But there's got to be a better way to do that. So I'm still messing around with that. All right. Yeah, you can never have too many cameras. Right now I have front camera, side camera, overhead camera, and microscope all running. And there are going to be more soon. All right. Thanks everyone for coming along. And as Aaron says, we're 95% of the way there. So hopefully on Sunday I'll have some good news on the Ethernet debugging and make some progress on that. And we can start on the mechanicals, and I can plug this in and actually start controlling lights. Okay. You're not going to leave unless I leave, so I've got to leave first. All right. Here we go. Good night.